Section 6.2, Properties of Power Series. Now this theorem 6.2 says combining power series. So it says suppose that the two power series, the series Cn(xn) and the series Dn(xn) converges to the functions f and g respectively on a common interval I. Then the power series Cn(xn) plus the Dn(xn), if I just put them together in a power series, then they converge to the f plus g or the f minus g. So it's saying it works across addition and subtraction when I talk about this function representation of this series and this function representation of this series. That if I take those and I add them together, I can, if I know the functions, I can just add those together. And that's going to be the power series representation of those functions added together. So that's kind of nice. So it kind of goes both ways. So if I was given two functions added together, I could come up with the two separate series and then just add them together or subtract them. So very nice property, and we're going to use this in this section. So the next thing is, the second property says, for any integer m greater than 0 and any real number b, the power series, here, this bxm cn(xn) converges to bxm fx. Now, this took me a minute when I looked at this. I was like, whoa, hang on a minute. But if you notice down here, that's n equals 0. So this is really the series that I'm looking at here. This bxm actually is not even referred to in this series. It's like the constant. So in a sense, I can just pull it out. And then I could take the function representation of the rest of this, and that would be my f. And then I would bring that bxm back in. So we've already used this property previously. So this isn't a big deal. Here, they're just formalizing it for us. So now the next property here, this third one, this is for any integer m greater than 0 and any real number b, the series blah here converges to f of everything inside of there. We've actually used this one as well. And this was the one we used. So remember we had the function 1 over 1 minus x squared. And when we came up with the series, we said, hey, that series is n equals 0. And this turned out to be just x squared to the n. Now, this bxm is just this x squared for us. And then if I turn it into the series, hey, I'm just going to plug that in here. And that's really what we did here. That's all we did. So this is the rule we actually used as well. But like I said, again, here they're formalizing it. So now let's move on to some really fun. So now let's deal with some fun problems here. So we can deal with this first property now that we haven't used yet. So here goes one here. Okay, so this says find the power series representation. F of x is 4 over x minus 3 times x plus 1. Okay, so the first thoughts here for me are partial fraction decomposition. So that's what we want to use here. Do you guys remember how to do that? Maybe, maybe not. If not, go back. Email me. We can talk about it. We can do a Zoom meeting. Whatever we can do to get through it. So if you need help with that, let me know. But this one turns out to be these two things here. Should have extended that. Okay, so there it is. So now what we're going to do with this is we're just going to treat these kind of individually to find out the power series for these individually, and then we're just going to, in a sense, put them together. Okay, so the first one we're going to look at is this 1 over x minus 3. So now I can write this way here. Because again, remember what I'm trying to do here. I'm trying to get it in the form of 1 over 1 minus x. Because I know that this equals, and that's where I'm trying to get to. So this is getting closer now because I moved the letters around and the number around. So now I have to get this a 1 minus x of some sort. So now some of you may have thought I could do a 1 over negative 3 minus a negative x. But this still isn't enough because this here has to be a 1 somehow. So that way it's not going to work for us. Notice this. Now this is something you may have not noticed previously, even with the other problems. What if I pulled a negative 3 out? So this is going to be a 1, that's going to be a minus, and over here I'm going to get an x over 3. Now that works because this now is a 1, I have my minus, and then this is some x stuff going on here. And that's okay. We'll deal with that x stuff as it comes up, but this is actually the way we want to go. So from here, what can I say my power series is? I don't know. Let's take it a step further. So if I pulled out the negative 1/3, I can look at it this way now. Okay, now inside of there, this is just that composition rule that we used previously. So this would be the negative 1/3, and I'm just going to leave that to the outside. And then to the inside, the series, I'm going to get x over 3 to the n. Okay, so that's going to be my first piece there. So now I am going to separate these, possibly. I don't know. We'll see how the other one turns out, and then we'll determine if we do that or not. Okay, so anyways, so now let's move on to the next one. That's the power series for the first. So the next one's just going to be the 1 over, and you could take the negative along with it if you want, but then realize I'm adding. So x plus 1. So that's going to equal negative 1 over 1 plus x. And this is really negative 1 over 1 minus, or I should say, minus a negative x. Okay, so that's this series here. So now if I pull a negative 1 out, I'm going to get here 1 over 1 minus negative x. And then using that same idea again I did for the previous one, that's going to be negative 1. And I have this series of n equals 0 to infinity. And this is going to be negative x to the n. And I'm going to clean this second one up just a little bit more. So I'm going to have this negative 1, n equals 0 to infinity. And then in here, I'm going to have negative 1 to the n, and then x to the n. And then now what I'm going to do is, looking at that piece there, this is, I'm going to bring that negative 1 back in, that's on the outside. So I'm going to get this series n equals 0 to infinity of negative 1 to the n plus 1 to the xn. Now that's the series of the second one. Now I can just go and put all this together. And I just noticed this, actually for the top, I can kind of do the same thing. Pull that 1/3 back in. And that would give me kind of like I did the other one. So that's going to be 1/3 n plus 1 times x to the n. And then put that one in instead. That'd be a little cleaner, I think. So notice what I did. And also, this is one thing that might catch you up. There is a plus here now. And the reason why that is, remember I pulled the negative in here. And not just that, I took the negative when I took the function to begin with. So just kind of keep that in mind. So that's going to make it a plus now down here. Right here. So just kind of keep that in mind. Now the final step for this is going to be, I'm just going to put these together now. So here we go. So here's our final answer. Now notice what I did is, since these are just the coefficients of both of my xn's, I can just kind of put them together in a parenthesis or a bracket, however you choose. And then just realized that I had a minus out front, and that's why I have a minus here. And then to the x, to times the xn. So that's going to be our final answer for this one here.